In this lesson, we'll get an introduction to cubic functions and learn how to transform them left, right, up and down, vertical stretch, horizontal stretch, and so on. So before we get too far, we want to make sure we establish our parent graph f of x equals x cubed, and we can easily get that by setting up a table of values for x and y. So if we plug in, let's say -2, -1, 0, 1, and 2. -2 cubed means -2 times -2 times -2, which is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is +8. And so our graph is going to go through 0, 0, 1, 1, 2, 8, and -1, -1, and -2, -8. And so our curve will look like that. So that's our parent graph for f of x equals x cubed. Typically, we'll use at least these 3 points as reference points when we transform the function, and so we'll constantly refer back to this graph with those 3 points. Okay, so what we're going to look at is when we transform this function, we can transform it by putting a multiplier in front that would cause vertical stretch or compression. B is inside the part that's being cubed. It's inside the parentheses, and that is horizontal stretch or compression. And then h and k, just like what we've done with previous functions in the past, h is horizontal shift, and k is vertical shift. Okay, so we'll look at some examples of how to apply those constants a, b, h, and k, and how they affect this graph. And so for this function, we're going to have a vertical stretch by 2. Which means we're going to multiply all the y values in the parent graph by 2. And then this is going to move it right 1, and this is going to move it down 1. And so if we start with our 3 anchor points from our parent graph, all the y values are going to get multiplied by 2. So this one has a y value of 1, and so when we multiply by 2, it stretches up here to 2. 0 stays at 0. -1, when we multiply by 2, becomes -2. And so that causes a vertical stretch to our graph, so now it would be a little bit steeper. If I had applied that same multiplier to this original parent graph we had up here, the next points would be 8 and -8 would become -16 and +16, and so those would be pretty hard to get on this graph. So that's why I just focused on those 3 points that are close to the origin. Okay, so now this blue dotted curve, we're ready to shift it right 1 and down 1. So every point is going to go right 1 and down 1. So this point, right 1 and down 1 goes to there. This point, right 1, down 1 goes to there. This sorry, that's should be this point, right 1 and down 1, transforming the blue points, not the black ones. And this point, right 1 and down 1 is here, and so now our curve looks like this. Example B is similar, except for the 2 is inside, and so that means 1 over B equals 2, which means B equals 1/2. And so that's going to cause a horizontal compression by 1/2. So go ahead and pause your video and try this one out and see if you can get a good graph for this transformation. Okay, so we'll start again with our parent graph. Now I'm going to scale it. I'll call this 1 and 1 and -1 and -1. So our parent graph would have 0, 0, 1, 1, -1, -1, and it would look like this. And now we're going to horizontally compress this graph by 1/2 because B is 1/2. And so that means all x values, this point has an x coordinate of 1, 1, so the x values are going to get cut in half. So now it moves to here, it becomes 1/2, 1. And 0, 0 stays 0, 0, and then -1, -1, when we multiply the x coordinate by 1/2 becomes -1/2, -1. So that moves this way to right here, sorry, to 1/2, which would be right here. So that point moves to there, that point moves to there, and so now we have our new points with the horizontal compression. So this would look like this now. Okay, there's our horizontal compression, and then we're going to move it left 3 and up 4. So these 3 blue points, left 3, 1, 2, 3, up 4, 1, 2, 3, 4. So this point, left 3, up 4. This point, left 3. Oh, let's see, I actually only forgot my scale was by 1. So to go left 3, I have to go 1, 2, 3, and then up 4, 1, 2, 3, 4. So that's going to be way up here. This point at the origin is going to go left 1, 2, 3, and up 4, 1, 2, 3, 4. And this point, left 3, 1, 2, 3, and up 4, 1, 2, 3, 4. So we have those 3 points, and then we can draw our curve through those 3 points. So there's our transformed graph. For example C, we have a multiplier in front of the parentheses, so that is going to be, in this case, a vertical compression by 1/2. and also a negative sign, which is going to flip the graph upside down. And then the 3 inside is going to move it right 3. So this is vertical compression. We'll get that by multiplying everything by 1/2. All the y values, that is, by 1/2. And then the negative sign is a vertical flip. And then right 3. And so our parent graph would have 0, 0, 1, 1, -1, -1. It would also have 2, 8. I'm going to include this time because we're going to multiply by 1/2, which is going to kind of bring it back into our grid. 1, 2, 3, 4, 5, 6, 7, 8. So there's 2, 8. And -2, -8 would be down below here. So when we multiply all those y values by -1/2, this one at -8, or at +8 up here, when we multiply the y value -8 by -1/2, that gives us -4. So 8 times -1/2 is -4, so that's going to be down here. 1 times 1/2 times -1/2 is -1/2, and then 0 stays where it is. -1 moves to +1/2, and then -2, -8 would become -2, +4. And so now with that vertical compression, now our graph looks like this. And then we're going to move everything right 3. So this point would move over right 3. This point moves right 1, 2, 3. This point moves right 1, 2, 3. And this point moves right 1, 2, 3. And so now we have got to go through this point as well. The origin moves right 1, 2, 3. And so now we have that graph is our final graph. In the next two examples, we're going to be given a graph and asked to write the equation. And it's nearly impossible to determine from a cubic graph whether there's horizontal stretch or vertical compression, because they both look the same on the graph. And so that's why in the equations they indicated whether they wanted us to include a constant for A, or in this case, a constant for B. So rarely do we have an A and a B, because, like I said, horizontal compression is going to look the same as a vertical stretch on a graph. And so at least on these cubic graphs, that's true. And so we kind of have to know whether we're supposed to be changing it horizontally or vertically. And so for this first graph, it indicates that there's an A value, which means there's some kind of a vertical stretch or compression. And so we can see our parent graph, which would normally, if this is our kind of where our origin used to be, we would normally go over 1, up 1, and over 1, down 1. So on our parent graph, normally we have, if you think about just a normal cubic graph, we always have these 3 points as our 3 anchor points. So this vertical change now is up 3, and so it's a vertical stretch by 3. And same thing going downward. This used to be a vertical change of 1, and now it's a vertical change of 3. And so that tells us that A must be 3. So a equals 3. And then the origin has also been shifted left 2 and down 2. So left 2, down 2. That means h equals -2 and k equals -2. And so our equation is going to be g of x equals, we said our vertical stretch is by 3. So 3 times x plus 2 cubed minus 2. Okay, go ahead and pause your video. Try number 6. See if you can figure out what b and h and k are, and then press play when you're ready to check your solution. For this one, if we can kind of superimpose our parent graph here, we can see what has happened. We know we're looking for a horizontal change because we're looking for a b value, and it looks like horizontally this horizontal distance, which is normally 1, has been stretched to 4. From the origin point, it's moving out. We go up 1 and over 1, 2, 3, 4. So that means b is 4. Same thing happens down here. We're moving over. We used to move over 1 and down 1, and now we're moving over 4 and down 1. And so b equals 4. That's a horizontal stretch. And the origin has moved right 1 and down 1. So right 1 means h equals 1. Down 1 means k equals -1. And that's because from the origin to this point at 1, -1, it has moved right 1 and down 1. So our equation then would be g of x equals 1/4 x minus 1, 1 cubed, minus 1. And that's it for today's lesson. Have a great day.